And so we're back, and we're going to start talking about pointers again. There's a brief game plan down here. I highly doubt we'll get to all of it in this one video. As we talked about in the first pointer video, which was probably 20 back at this point, pointers are tricky concepts. And the reason why we went off on a tangent there and started talking about variables and memory locations and messing around, looking at the black box and memory management a little bit, is because pointers and we'll just say pointers in general require some understanding of that. Do you have to absolutely know how the operating system and in the environment of an interpreter or something is shuffling memory around and things like that? Probably not. But having some understanding of how variables are created, how their values are stored, and understanding that there's an intermediate step between referring to a variable by name and getting the value back. That there's a black box there that's doing some crazy things. That is, if you really want to understand what you're doing and what we're going to start getting into with Cheat Engine and finding dynamic or finding pointers to different values that persist every time we restart the game or load a new game or something like that, there is some fundamental level you have to understand memory management in general. People will disagree with me on this. There are videos out there on YouTube where people are, basically they're saying, oh, you want to find a pointer? Well, here's what you're going to do. You're going to open this up. You're going to go to Cheat Engine. You can attach to some process. Okay, well, you can attach to something that's not that process. Go with Firefox. And then what you're going to do is you're going to search for some value. And then you're going to come down here. You're going to, maybe this is the value that we want. After filtering it, you're going to right-click on it. You're going to go to find out what accesses or writes to this address, or you're going to go to pointer scan. And, all you got to do is click here, click that, cut this, paste that. That's not the approach that we're going to take. Clearly, if you've made it this far and you've watched everything in this series, you know that that's just not how I roll. Do I want to know how to use a program to accomplish what I'm doing? Absolutely. That's the whole point of a program. But I want to know what exactly is being done behind the scenes. There's a number of reasons why I want to know that. One, I'm just happen to have some sense of curiosity. The other is that things are going to go wrong, especially as we start getting into some of the more the deeper things related to pointers and things like that. These are error-prone things. It's very difficult sometimes to quantify exactly what you're trying to do to Cheat Engine. It's going to do what you tell it to do, but we're, as a user and as a human being, will probably make small mistakes here and small mistakes there. And these are multi-step processes. So if you make one small mistake, and you're dealing with 20 million records, and then you try and filter that down to 2,000. If you made one small mistake in that step, and then you sort of start building on out, you're not going to have you're not going to be able to find the value or the values, or the pointers, whatever you want to say, that you're looking for, and you're going to have to sort of backtrack. And if you don't understand the implicit process of what's going on, it makes it very difficult to sort of say, all right, well, maybe I screwed up here and I want to go back to that step. Instead, you're going to have to redo the whole process. So that's certainly what I would consider the most relevant reason as to why we're going over some of basic memory management and things as far as computers go. But again, also I just happen to be naturally curious. So we talked in way back when about how there's sort of a demarcation point in this video series about if to go any further than this, you're implicitly saying yeah, I want to know some basic concepts about computer science. We're going to make another disclaimer like that. If you made it past that first sort of demarcation point, you made it through the last videos, some of which maybe weren't as coherent as they could be if I had a formal plan. Then we're gonna sort of demarcate this again and say that we're gonna start getting into some pretty abstract things all related to indirection. Is sort of a technical blanket term that we're gonna use, or that is used in computer science to talk about some of these concepts. And what is indirection as a concept? We'll get into that. But again, we're drawing a very clear line in the sand that we're gonna go even deeper down the rabbit hole and start talking about pointers, maybe even a little bit about references. We're definitely going to get into hexadecimal And this is, to someone who writes microcontroller code, is this advanced stuff? No. This is something they deal with on a daily basis, but we're obviously not going to be doing any of that. But for the general audience, and for the average user of Cheat Engine, this is stuff that most people don't deal with in their professional lives. And there's a reason for that. And there's a reason why concepts like pointers and things like that are abstracted away in higher level programming languages, because these concepts are hard to understand on some sort of natural level. And so basically, as programming languages have evolved and they've started operating, at a higher level, sort of each iteration of or each generation of languages, they abstract more and more away from the average programmer. And the reason for that is productivity, among other things. But a driving force for that increase in product, or a driving force behind that increase in productivity, is that these are complex topics. And when you start adding, doing pointer arithmetic and things like that, it gets very complicated very quickly, and it's very easy to mess up, and create bugs in your program that'll either crash your computer, crash your application, something like that. So let's move these down a little bit so we can sort of see a little bit better. Our new wallpaper here. If you know the output, or if you know output, go on vacation. That's funny. Why is it funny? Because this is sort of I don't know. Is this actually C? It looks C-ish. Um, some syntax, some knockoff of C. What's it doing? It's making a pointer of a character data type. It's naming that pointer P. It's allocating some memory for it with new. And then we have another data type here. It's going to be 12 bytes long, 12 characters, however long that data type is. We're just going to assume it's 1 byte. Then, we're saying, well, let's grab the value of that pointer, set it to this value. We're going to add something to that. We're going to set it to this value. Then we're going to add something to that. And then we're going to go there. And it just, are we going to deal with stuff like this? No. But this is totally valid, and this clearly demonstrates that you can do some incredibly complicated things with pointers, and you can do those things in a way that is not readily obvious, even to people who understand pointers, because I have no idea what the output of this is. I doubt anybody does. Um, and so, again, we're going to use that to illustrate the point. Totally valid. Could we translate this code into Python? Maybe. But this is valid code, and code like this probably exists in a lot of the source code for a lot of programs. I'm sure something like this probably exists in the Windows source code. So again, let's just say that we're going to leave it at that. So we're going to go back to Wikipedia. We brought up this article before in one of the videos, so we'll jump into some of the stuff here. But if we can sort of illustrate the process a little bit, see if we can make this a little bigger. We can't really, but we'll go with this. So you can see basically we'll go with this. There's a picture. There's 3 columns here, and in the normal way that we've been describing variables, there's a name of a variable. It has some memory location, and then there's a content, or a value of that memory location, or in this case, the storage address, using the term synonymously. And in every example up to now, the value or the content, again, synonymous terms, the value or the content of the variables that we've been referring to have just been, like 5 or 2 or 100 or whatever value we're interested in. A pointer is a sort of an abstraction on that, or it is an abstraction on that concept, where a pointer is a type of variable. So we have a variable. That pointer itself has a name. There's a name of the pointer. The pointer itself has a memory location, so it's a variable because it has a memory location, and then it has a value. What is the difference between a variable and a pointer? The fundamental difference is that the value of a pointer in memory is another memory address, and it will point to another variable or another location in memory. So, well, that's not a very complicated topic or a concept. That is an extremely complicated concept when you apply it to programming and theory in general. Bring that up. When you apply it to programming in general, and especially when you get into modern applications and things like that are written in high-level languages, there's all sorts of crazy stuff that goes on under the hood that is built on this fundamental concept. So let's go back to the article, see if we can see if the article agrees with what we just said. What did we just say to sort of recap before we jump into it? Pointers are variables that have specific memory locations associated with the name of those variables, just like we talked about, just like regular variables. The only difference is that the value of a pointer is itself another memory or another storage address or another memory location, whatever you want to say. And then so when you pull out the value of a pointer, it's going to just sort of, it's going to give you an address that if you go to that address, it's going to give you another variable. And that's what we're going to say. Let's see if this article agrees. Or get a little bit of time. In computer science, a pointer is a data type. We're going to sort of pull out some words here. A pointer is a data type whose value refers directly to another value stored elsewhere in the computer memory using its address, or it points to another value stored elsewhere in the computer memory using its address. For high-level languages, pointers effectively take the place of general-purpose registers in low-level languages such as assembly code or assembly language or machine code, but may be in available memory. We'll get into assembly and general purpose registers when we start doing assembly script and things like that. And you'll see that there is, in fact, a correlation between the purpose of some registers in the processor versus the concept of a pointer in programming. A pointer references a location in memory. We'll talk about why that's italicized in a second. And obtaining the value stored at that location is known as dereferencing the pointer. We're not going to sort of dive into dereferencing pointers. We're just going to we may have to at some point, but we're going to try and be as general as possible. A pointer is a simple, more concrete implementation of the more abstract reference data type. Are we going to jump into references? We will for a second. Several languages support some type of pointer. There are more restrictions on their use than others, or in some languages there's more restrictions than others. As an analogy, a page number in a book's index could be considered a pointer to the corresponding page. If you dereference that pointer, or you tell the computer, hey, I want the value of this pointer, it's going to come back and it's going to give you the page or the content on that page, which would be the equivalent of flipping to the page that is to the given page number as pointed at over here in the pointer. Why do we use pointers? Well, they improve performance. There's a whole bunch of stuff about that, and we can talk about how the pointers help implement functions and subroutines and things like that. But we'll get into that at some point later. What's a reference as far as pointers go? Reference is a value that enables a program to indirectly access a particular piece of data, essentially what that word means, to access a particular piece of data, such as a variable or a record, in the computer's memory or some other storage device. We're not going to bother really sort of quantifying that. The reference is said to refer to that piece of particular data, and accessing the particular data in question is called dereferencing the reference. Dereferencing the reference, really. Let's see if we can maybe get into something here about how references and pointers are related. We'll go down here. Pointers are the most primitive example of a reference. Due to a pointer's intimate relationship with the underlying hardware, they are one of the most powerful and efficient types of references. However, due to this relationship, pointers require a strong understanding by the programmer of the details of memory architecture. Because pointers store a memory location's address instead of the value directly, inappropriate use of pointers can lead to undefined behavior. Smart pointers are opaque data structures, yada, yada, yada. So we can see that the Wikipedia article here is sort of correlating what we were just talking about in the beginning of this video, is that pointers are somewhat as a concept. When you're trying to explain this to people, you're like, okay, here, this is complicated. We're going to jump into it. Here's the general idea of what a pointer is. They're like, that's not so crazy. It is crazy. And Wikipedia, obviously is it completely authoritative? Probably not, or just no. But generally, it is a good, especially when it comes to computer science and technical articles. It is a very good way to sort of read about some of these topics. And right here in examples, it's basically telling you pointers are powerful, they're efficient, and the whole concept of pointers and their relationship to computers requires an understanding of memory architecture in order to use them. And if you use them wrong, undefined behavior. What is undefined behavior? Well, undefined behavior is basically what we were talking about. You're going to get spurious results. You're going to crash your application. You're going to jump way outside the memory associated with your process, and the OS is going to trap. You can do all sorts of crazy things, and we'll we'll talk more about this in the next video.